Hello, welcome back to BlenderSushi Live Noding. In this video, I'm going to explore Sverchok bounding box node and show you how we can create a setup that looks like this. If we want to roll an object and we want objects to make sure it's always on top of the ground, it's never kind of touching the ground. This is actually something that I found out by accident. Let me delete the driver here and let's see what we actually got. So we have this Suzanne head, and as you can see, it's the ones on the bottom here, it's always on top of the ground, regardless if I move Suzanne in any kind of positions. What's happening here is actually the bounding box is always trying to maintain its position on top of the ground, and that's actually how I got started to creating a setup like this. We're gonna deal with a bounding box, so let's just get started. So what is a bounding box? As you already know, if you have like a bunch of objects in the scene, like let's say a torus and then the monkey head and something like a cone, we have them on a 3D view, and if we switch to the bounding box here, all objects will become just like a box, and they also have some kind of transformation applied to the box. So that's actually something that you can observe also via this panel. It's showing the dimension of each object in the, if you imagine like a width, height, and depth of an object. Where is it? Let me find it. There you go, the dimensions. It's a kind of like a representation of the object as a 3D bounding box. We can change it from here and it will update itself, and the bounding box also will change accordingly. We can apparently do that the same thing using Sverchok, and furthermore we can kind of use that idea just to place objects on the ground. I know that in Houdini, another 3D package, like a procedurally, you can place objects on top of the ground. If you if you know the bounding box and you find the center point of the object, and based on the maximum dimension of the objects, we can kind of find the bottom part of the objects and then to place the objects on the ground. So that's kind of the whole idea. I always want to do this using either Python or something like Sverchok. So let's do that inside Sverchok. So this is gonna be bounding box placed on the ground. We can use the monkey head or just use a torus for now. I can rotate the torus just so we don't have so we can see it more clearly. Okay, let's jump into compositing, turn on Sverchok, and let's source the object first, and let's look at the result. So by default, this is what you should get. The reason that the Sverchok object is not like this objects in the scene is because we need to apply the matrix. So that's the next thing we need to do. Because if we use the bounding box node right now, and I create another viewer draw, so if I plug this in there and that guy into that guy, and then you can see the result is like the objects in the original positions. We don't want that. We want the objects to be over there. So we need to use matrix apply node, apply the vector and apply the matrices. This is like the transform of the objects in the 3D, kind of into the world space. And now we should see the bounding box is in the right position. And the same thing if we plug this into that guy, so that's resulting in the Sverchok objects in the correct position. Let me delete that. So we just now want to see the bounding box. If we compare the bounding box that we have at the moment from Sverchok with the bounding box in the viewport shading, you can see there's a difference. That's because this is kind of like if you imagine the original bounding box and then transform into the position. We don't need to worry about that right now. What we worry is just this bounding box, kind of like after we apply the transformation into these objects. Because using this bounding box, we can really find out how, if we want to place this torus into the ground. Like if I bake the bounding box and see I get this object, I need to set the origin. Now if I reset the position, now if I lift it up certain value in the Z, see I get the objects in the on top of the ground. That's exactly what I want to do. In order to do that, I need to do a couple of things. First of all, I need to reset the position of this bounding box into the center first. And in order to do that, I need to use something in the transformation. I think in the transform we have, this is all you can do, like if you want to change the pivot position of the objects, whether it is for rotation or scale or move or other stuff, what we need is the move. And let's see, I believe we have the bounding box. Let me have a think. I think the multiplier should be -1, and if I pipe in the vertices there, and the vector, we need, if we get a vector from this guy, from matrix out, from this guy into that guy, so we have, now we have the bounding box at the 0, 0 position. It's kind of like inverting the matrix. I think that's really what's happening. So that's kind of handy. We almost kind of done with this. What we need to do next though, it's we need to observe this guy. So we have the bounding box, and then like I said in Houdini, in order to place the objects on the ground, you find out about kind of the height dimensions and cut it into half, and based on this value you just need to drag and translate the objects half of its height, and you will have the objects on top of the ground. So let's do exactly that. We just need to find out the height dimensions, like the max dimension of this box. So I can hide this now. Let's observe that using index viewer. I want to know the vertices. What's the exact like the points we have here. The bounding box itself, it's really useful because it's giving you this 8 points, like a vectors on a 3D space that you can use to find out about the height or the depth. And all we need to do is kind of in this case we can just subtract the vector of located in the corner, top corner, divided by no, like subtracted by the vector at the bottom there, and we get the height. So that's exactly what we need to do. So I'm gonna use the list item, and we have the bounding box here, so I'm just gonna grab the data. Currently, if we observe the data from bounding box, it's giving us this vertices. I better use the text viewer. I think it's clearer. Viewer text. Plug that in, and let's have a look at the text editor. We can see there are 8 points, and we only need the points at index 4 and index 0. Index 4 and index 0. Okay. So, and if we subtract the vector, actually we just need to find out the distance. The distance between those 2 points is going to be the height. So this and this, if I just frame it, join in new frame, this is to get the height. If we observe the value, now we can see it's a 1.8. So that's actually correct. If I bake this guy and then have a look in the dimension, you can see the dimension is 1.809, so that's exactly this number. So that's good. And the next thing we need to do is just to divide the number into half. Divide it by 2. And we can now use that number to kind of bring this back to 0, 0, 0 and then lift it up. Or in this case we don't need to bring it to 0, 0, 0, but just to be clear, I'm going to do that. So I'm gonna place the torus back into 0, 0, 0 position first. And that's if I use this and this. There you go. I'm just doing the same thing. I'm applying the same kind of transformation into this guy. This guy can be in anywhere in the 3D view, but I just want to place that guy at 0, 0, 0 first. And all we need to do now is to bring this guy up using this value, which is just a half size dimension of the height of this object. And we can use the matrix for that. Matrix in. And let's actually do that to the bounding box for now. the matrix location. Okay, matrix in, and let's see, vector in into the locations, and then this in the Z we just bring it up. So there you go. That's it. We have like a ground plane. We can see that the bounding box is exactly on top of the ground. It's not intersecting. So that's perfect. Let's apply that into our torus, and we are pretty much done. There you go. That's exactly what I'm trying to do. Let's turn off the points, turn off the edges, turn on shading. Now if I rotate this guy, you see it's not updating, but if I just scrub on the timeline, it's should be updating fine. If I play back the timeline and then do any rotations to the donut, now it's as if we have some kind of simulations going on, but it's really just the bounding box doing the thing. I can scale it up, scale it down. It's still gonna work. And if I change this to the monkey, so it's monkey head, and just get selection, the monkey is also placed on the ground. So if I rotate it like that, you see it's never touched the ground. Although there seems to be an issue there. That's the monkey is not really touching it. I think the reason being is it's because I should have used the mean, not the mean, but the center point of the objects. And let me see. Let me check real quickly. So the center. So there's a matrix apply here and the matrix out. We need the center points based on the bounding box, I think. So let me save this first and save it again. So let me check real quick in my finished version of this. So in this one, I'm actually using the center of bounding box and plug into that guy. So I'm using matrix out, get the location of the center of the bounding box, the exact center. That's actually gonna give the more correct result. So let's go back. We don't need this guy anymore. You don't need this, you don't need that. Cutting matrix out from this center and plug into that guy. matrix apply. Plug into this guy. So that's what's supposed to happen. Okay. So now the monkey is should be touching the ground. Let me check. Let's check from the right or view from the front. Use orthogonal. Now Suzanne is really placed on top of the ground and is now touching correctly. And we can make her kind of rolling like that. It's basically the bounding box is doing the calculations on every frame. We can rotate it so we can have like a kind of rolling stone kind of effect. If we change this into like a cube, for example, and just we can have this rolling cube effect. So that's really handy. I think this should be made into not like a modifier, but it's it can be used for animations. If you want to make sure that so you're gonna give the control to animators, and the animators can just translate it in the X and Y, and let the rotation controlled by the bounding box setup that we have, and that should work quite well actually. Can also be for like if you are doing like a rigging, you can have card with a like a box kind of the car can have like a box wheels, and the wheels can do rotation like this. Yeah, so yeah, that's that will work. And again, you can use the torus as well. The torus can rotate, maybe like that. Okay, so yeah, so that pretty much I want to show you today in this video. That's using Sverchok bounding box, just to make sure, just to have this setup where an object should be always touching the ground, but it's on top of the ground as well. And if you want to have a look at the setup once again, I'm gonna tidy up a little bit. So this is the objects. We have the matrix apply for the objects, and we have this bounding box. We get the height dimensions, and then for the we have the center, and we offset it. So we offset the position of the objects half of the height, and so that's the whole kind of setup, just to place an object on top of the ground. So I'm gonna just make a quick doodle here. So yeah, that's how that's one way you can use this bounding box node. And yeah, so yeah, hopefully you find this video useful. If you have any question, just ask in the comments below, and give like if you like this video. And thanks again for tuning into this channel. I'll see you in the next video. Thank you.